Now you need to select the one which you have connected the coordinator or called as a base station. Select that particular COM port of that connected coordinator. It is highlighted over here, and you need to go to the terminal. So this is icon. Once it is installed here, once again I am just trying to show you from the beginning. Select the COM port. Go to yeah, I understand this one. This is the older version of XCTU. Yeah, I agree to that one. What happens is, why I have used that older version, I will try to give you some kind of justification. The thing is this, there are some modem softwares are there. So those modem softwares gets updated. Now once the modem software gets updated, and if you are using a modem which is the older one, may not support the latest one. So the one which I am using as a Zigbees, XBees which are series 2, which are older one, and the corresponding the mesh networking as well as the peer-to-peer networking softwares, the modem softwares are already embedded into this. So this software is also available on the net. Moreover, you can also download from this XCTU. Yes, older version is also available. Right. So here, once the terminal has been connected, you can see CTS, clear to send. Of course, you know that commands clear to send, request to send. For the UART data transmission, for the serial communication, you might already know those particular terminologies very well. I don't want to much discuss on these things right now. Right. CTS, clear to send, if it shows you the green color, it means it is ready to receive some data here. As of there is no data receivement here, just it shows a plain screen, is empty screen which is not receiving anything further. So once you get this particular screen, now you try to connect here. So before we start configuring, let me show you the data reception. Once you receive the data, then I will show you what are the things that are need to be configured. So how the data looks like, those are the things that are needed for you. So for our demonstration, I am just using a power supply here with the batteries that has been set up. Yeah, the 3 ordinary batteries, AA batteries, which each have 1.5 volts. Now you may ask me that the total is almost 4.5. Yes, the 4.5 also supports this one. But technically speaking, those values or data may not be accurate. Only thing is the allowable permissible values is the ranges from 2.8 to 3.6. This is the optimal range value. When I say optimal range value, within that particular range, you will get the data correctly that has been coming from these particular sensors as well as most of the other devices which are connected to this. Yeah, now you see the LEDs are glowing here, the power supply has been sent. Now you are receiving some data here. You may not understand exactly what that data is, but you are receiving some data. The data which is coming from temperature sensor, the potentiometer, as well as the digital signal that are coming from this particular PCB here. Now if you want to see what exactly the data is coming here, go to the show hex. Now these are the hex values. Please remember, most of the hardware devices, whenever you are trying to communicate, the data transmission will be in terms of hex values only. 99% of the data transmissions comes through your hex values. So from here also I am sending the data. That is what the continuous frames of data are being sent. You may not understand exactly what that is. Let us now try to understand how do you capture that frame and how do you store that frame into your computer and how the data can be used for our analysis. That is our point of discussion. So if you see here from a different points, a different corner, you can, if you make proper connection over here, the data can be easily received from that particular point. So just because my connection, the power supply connection is not proper, you may get continuous break. But if your design, yes please.
We are getting this data for only LED,
Not LED, ma'am. No. The three. It is not three. Yeah, no, it's not three sensors. Only one sensor is there, temperature sensor, and a potentiometer is there, as well as data related to that LED. Data related to the LED. As of now, if you see the LED is glowing over there, it means the high value of that LED is been, the data is also coming over in that particular frames over there. It is a continuous one. And one more thing, the data is not getting stored over there. It's just only for our view. The XCTU software does not provide you to store that frames. It only just show you that during the command prompt or at the command mode or the console point, you can just view that particular data, that's all. But data cannot be stored here. It means there is a proper communication. Just to understand that there is a proper communication between this particular sensor device and that particular base station. So once you see that particular frame, now what are the things that are needed for you to configure and how do you store the data is our point of discussion. Yeah, I'll just come back to the frame, sir. Now there is one more tab here called Modem Configuration. This is a Modem Configuration one. Now this Modem Configuration is nothing but the name itself specifies you the radio communication module that needs to be configured over here. Now the one which is already connected to my computer is the one which you can see here. This is the coordinator. Now this particular, if you press the read button of that one, you can see the one already which is configured over here. What are the parameters that have been configured? Let us see, try to understand over here. Basically, the basic information the modem requires is, these are the important things. Yes. So the basic parameters the modem requires are these: the networking parameters, the addressing parameters, the RF interfacings, security, serial interfacings, sleep modes, I/O settings, and diagnostic commands. These are the basic parameters that are to be needed for that modem to work properly. Now if you expand the networking, what are the important things that are required? So if you see here under the networking parameter, there are other sub parameters like operating channel, operating PAN ID, scan channels, scan duration, node join time. Now these are the sub parameters. Now when you are setting up a wireless sensor networks, the main important things are setting up of a PAN ID as well as the channel in which that radio communication still takes place. So what is a channel here? Obviously the wireless communication medium basically works or data transmission takes place in terms of channels. Now how many channels are being supported over here? The ZigBee protocol, or most specifically the XBee, the module which you are trying to see here, it's not the 100 channels are available for us. There are only 16 channels are available. Please make a note, 16 channels are there. You may use one of the channel for your communication setup of the corresponding wireless sensor network. When I say of the corresponding wireless sensor network means you can build up several clusters of wireless sensor networks in the same vicinity of this particular room also. Each wireless sensor networks will be having data transmission according to the channel which you have specified, so that the data transmission takes place properly. And each wireless sensor networks will have the corresponding coordinator which can try to coordinate as well as have communication between the corresponding node channels within the same frequency, the scan channel 1. So here one more important parameter is on the PAN ID, personal area network ID. The PAN ID is basically a 64-bit address which you need to specify so that all the communication modules or the networking modules or the sensor nodes which are having the radio communication modules will work in the same PAN ID, in the same local group. So if you have several PANs can also be made. Yes, please.
So each channel having some bandwidth?
Yes, the bandwidth is available here. So you have basically the XBee works with the 2.4 gigahertz frequency. So, the 2.4 gigahertz frequency is been divided into 16 channels of you are having around 400 to 500 megahertz frequencies of different channels of 16 one, you get it a different set of values over there. But more specifically they are around 2.4 only. It starts from 2.4 yes up to 2.5 you can go about it.
I think 2.385 to
2.38 is it around 2.4 plus or minus with having a certain bandwidth of certain range here. Yes, basically some are 40, some are 10 I think sir. Yeah. So, there is a range between that. You can see the data sheet of that particular ZigBee which you are trying to use over there. So, this varies from module to module again. Some may have 16, some may have 18, some may have 20 also channels are available here. The one which you are using on the series 2 is basically 16 channels are being used for that communication. Right. Now, the next one is on the addressings. So, here on the addressing you need to specify the destination as well as no need to specify the serial low. Serial low and serial high are corresponding to that particular radio communication module only. And if that radio communication module is trying to communicate with some other radio communication module which you are going to call it as a destination with respect to that the one which you are trying to use it over here, that destination address high and the destination address low also should be specified here. So, that is what here the destination address high and the destination address low which are shown in the blue color which are the new values here, and this is also 64 bit address here, the 64 bit address, and the destination address high is always fixed with respect to the DG modules 0013 A200 is the destination address high order bits and destination address low order bits of the corresponding 64 bit addressings here. So, now this destination values corresponds to this particular sensor node which I am going to use it here, the one which is connected to the sensor node. So, serial low and serial high, what are these serial low and serial high? Serial low and serial high are corresponding to the corresponding radio communication module. You need not set the values. This basically physical address, the physical address of that communication module. That physical address of the communication module is fixed by the DG manufacturer themselves. You need not change it. So, every communication module, every radio communication module which you are using has got a fixed address, the address which is specified by the manufacturer itself, which is a 64 bit. So, those 64 bit are corresponding to the serial low and serial high of that particular radio communication module. By using the software, you will come to know what is the serial high and serial low. This serial high and serial low corresponds to that particular communication module only. If you don't know the software or if you don't use the software, still you can just turn this particular radio communication module at the back side, you will have the corresponding serial high and serial low. That is nothing but equivalent to the physical address, the hardware address, and which is unique, and meaning of unique address. So, the like MAC address of your computer, similarly this is a unique address. This communication module will not have the same address to any other communication module, this is a fixed one. So, you can use these particular addresses. Remember, we are using these addresses still. If you want, we have used one paper for IoT related things. We have used these addresses to transform into a IPv6 address and send data through internet, and that particular paper will see how those particular addresses are useful for us. So, that this particular module can themselves be made use of sending the data through your cloud. That idea will come back to later, that is what. So, these addresses are basically the hardware addresses of this communication module which are being termed as serial high and serial low. And these two addresses, destination address high and destination address low, destination corresponds to this particular communication module which is trying to communicate to the sensor node which is a distance apart. So, that particular address, that address you need to specify. How do you know that address? Every radio communication module at the back side you will see that particular address of that particular module, or by through software you can view it, or by physically you can just see the particular address and note down the address on a paper, so that will be useful for our setting of the things. So, here the important thing is on the networking parameter you need to set the PAN ID is a 64 bit address, and you need to set the scan channels. These are the two important parameters that are need to be set. Coming to the addressings, you need to set, if you are trying to communicate with destinations a particular sensing node, you need to set the corresponding destination address highs. And coming to the next one, IO settings. IO input output settings. The input output settings, as I mentioned to you earlier, you have 8 analog values can be used, 8 pins can be used, and 12 pins can be used for our digital IO. So the number of pins, how many has to be used, which pins has to be considered for sending analog as well, which pins has to be considered for digital, that you know depending on your application. So here if you look for our this PCB, if you look to this particular PCB, for according to this design, the fabricated PCB module, according to this design, what we have done is the temperature sensor is connected to pin number 20. The pin number 20, what is pin number 20? The pin number 20 is nothing but the one which you are going to use it for your radio communication module. It means temperature sensor values are being sent through this particular pin number 20. The potentiometer values, the analog values are being connected to pin number 19, and the digital LED is connected to pin number 18. So once you push this particular radio communication module onto this fabricated sensor node, those pins are fixed. Those pins are being fixed here. Pin number 20, pin number 19, and pin number 18. I will just circulate to you PCB. You can see it freely on this. I have one piece with you. You can see it now if you want. Yeah, just circulate, sir. So the same PCBs are available with us. 6 of them are there. So now you can see here basically the temperature sensor connected to pin number 20 to receive the temperature sensing values, and potentiometer, one potentiometer is there connected to pin number 19. If you can see at the back side, the printed circuit board at the back side, you can see the design clearly there, which pin is connected to which particular sensor there. It is a very small design there, there is nothing but difficulty over here. So here you can see appreciate or you can understand how the pins are being connected here. So apart from VCC is connected to the 3.3 volts. The ground is the black wires. Ground is connected to pin number 10. VCC is connected to pin number 1. Ground is connected to pin number 10, and the pin number 20 is connected to temperature sensor. Pin number 19 is connected to the potentiometer. Pin number 18 is connected to the digital LED, and the reference voltage. You need a reference voltage for the ZigBee module, for the XBee modules. That is 3.3 volts, which is equivalent to the VCC itself. Those 3.3 volts reference voltage is connected to pin number 14 and pin number 16. That is the simplest design that we are trying to understand over here. With the same principle, once again I reiterate, whatever the principal concept of this design, with the same principal concept to interface a XBee module with the corresponding sensors. With that, there are several sensors which have been designed and developed at MASE under the Professor Subhash guidance. So that design comes, the logical part of those designs will come later. But if you can understand this principle very well, the concept of this design, how do we sense and how do you receive it, then that same principle works for using several other modules to be designed and collect the sensor modules and do some kind of data analysis accordingly. So that's what, please try to focus on this particular design which is circulated here. So,
It need not be pin 20 or 19.
yeah, of course, I understand that. It need not fix that pin 20, 19, 18. For just understanding purpose, we made a design like this. That's what you can use 8 of the pins as analog, as well as 12 pins can be used for a digital one. You can differ according to your application requirements. That differs from your application to application. But in this application, we just fixed up for that particular understanding purpose. So once, yes, those pins are to be configured here. That's what. When I come to IO settings, that's what I said, input output. This temperature, potentiometer, as well as the digital, they are nothing but IO values, input and output for our application here. Those corresponding IO values needs to be set up here. Those IO settings has to be done. So which particular pin has to be used? As I said here, pin number 20 is connected to temperature sensor. What is pin number 20? Which is equivalent to AD0 or DI0, D0. That is this particular one, which shows here the first value. Now from where you get this information? This information you can get it from the XBee data sheet. In the XBee data sheet, they will give you pin number 20 is equal to AD0, pin number 19 is equal to AD1, analog to digital means analog or digital value 1, pin number 18 is equal to AD2, pin number 17 is equal to AD3. It means you can use those pins for your analog as well as digital transmissions. But only thing is you need to configure them. But since what I am doing is I am now using the coordinator. The coordinator doesn't require the IO values. Only the sensor, only the end device, the sensor which has got these sensors, they require the IO settings. The coordinator does not require the IO settings. Please make a note. The coordinator requires only the PAN ID, the channel with which the communication should take place, and the data rate which you are sending a digital signal, what is the frequency or the data rate or the sampling rate that you need to use for your communicating between the coordinator and the device end. So those for the coordinator as of that doesn't require such kind of values, IO settings. But when you configure the sensor devices, that you need it here. That will come back to this. So another important parameter here is the IO samplings. So if you are using, if you are trying to send some kind of values, now at what rate those, yes please.
We are using reference voltage of 3.3.
Right.
We are also using VCC.
Yes.
Actually, we are using.
The reference voltage is basically used for our analog to digital conversions, sir. Analog to digital and digital to analog conversions. So the basic voltage is 3.3, that is for the power supply of this one. The same 3.3 is been used as a reference voltage. It means the same value can be connected here. You can see the 14th and 16th pins. Why reference voltages are required? Those analog to digital conversions, you know that there is a conversion process for an analog to digital values. For that, yes, that digital signals has to be generated. The 3.3 volts, that is the cutoff value for that one. So that's for conversion from A to D and D to A, you require a reference voltage for that. And that is taken care by the internal microcontroller over here. We are not having any microcontroller separately here. So just we receive the hexadecimal values, and those hexadecimal values are converted to the numeric values. That process I will tell you how to do those things later.
It means that externally we just have to provide VCC. It is automatically reference voltage is automatic.
Yeah, means because since in this particular ZigBee modules the reference voltage is also 3.3 and our VCC is also 3.3, what we have done is we just connected whatever the voltage goes to the VCC, it also goes to the reference voltage pins. There are two pins which are meant for in this design actually.
It means that pin number 1 and 10 is just replica of 14 and 15.
No. Pin number 10 is ground. Ground is not a replica of 14 and 15. 14 and 16 are nothing but equivalent to pin number 1. Pin number 1, whatever the voltage comes here, it also goes to pin number 14 and it also goes to pin number 16. Same 3.3 volts goes there. Pin number 10 is ground only there.
So one thing more, while configuration of this, because this is not a coordinator, so I have to connect this to this.
Yeah, that's I am going to show you, ma'am. Just how do you put you have to pop it out, means you need to use the same explorer and push back the other XB, so that XB you are making it as a device end. Yes, so the configuration values will be differing.
That means same chip would be configured as a coordinator and it can be configured as a sensor.
Same device end or a router, you can make it as a device end, but the parameters will be different. That is what. And the radio communication takes place with the help of ZigBee protocol standards only. The same ZigBee protocol standard, whatever how the communication should take place. Usually the security point of view, basically direct sequence spread spectrum. Direct sequence spread spectrum is the technology which you are trying to use it for sending the data over this particular channels, wireless channels. That is already been inbuilt, taken care by the manufacturer themselves. We are not bothered about the basic setup of wireless communication. We are taking the help of this XB module so that our data can be transmitted to a long distance. So that we are concerned about data collection, data storage and data analysis for this particular set of hardware device. So that we can avoid our time consumption can be minimized, our consumption can be eliminated if you are not playing with this communication module. Otherwise, if you are trying to design your own communication system, then the things will be very haphazard. It means it will take a lot of time, entire project time will be over, you may not have that much of time to complete the project also. So usually students' point of view, they will not have 6 months, usually the project time is 6 months or 1 year. Between that 6 months or 1 year, you need to be able to complete the project. If you start designing only the wireless communication system, then it will completely eat away your time of 3 months or 4 months. To avoid that particular time, because they are already available on the market, you can just grab those ZigBee modules, use it for our application purpose. You just try to configure according to your wireless sensor network and try to send your data and try to play with the data later.
Sir, am I correct? Then it doesn't make any sense also to design a separate wireless sensor network, because I have to go for altogether that ISM band and altogether a new modulation technique.
Exactly. Yes, that is entirely a different aspect actually.
There is no sense of making.
Yes, there is no sense of making a new set of communication module, because already much research has been taking place, much advancements are taking place in this one. You just need to buy from the off shelf. Yes, sir.
No, actually we can give a break for 15 minutes for tea.
Okay, so then I'll just show you the configurations, then the software design, which is the most important thing, then we'll come back to the discussion later. Thank you. We had developed earlier the GUI, which is already showing the temperature is around 18 to 19 degrees, but sometimes you are getting more than 19. So if you can see the sensor temperature one 18.95 or 18.5, now it is showing 22, again it has changed back to 19. Now the 22 is the limit what we have put it through the software, but if you see on the real temperature is around 19 degrees. So that's what the sensor temperature, which we now trying to show it on the GUI, as well as we are trying to now save it on the file also. That let us see how to complete that particular GUI completion. And now the second reading is on the potentiometer, which shows you 3.3 as well as with some other values 0.2. Now when this particular thing has been shown, the 22 degrees is nothing but the spikes, the readings which are not accurate actually, because the one which you are now what you are seeing is not properly connected, not properly designed, not properly developed here. So once if you put a particular system wherein in proper data accuracy is to be required, obviously the system should be in a proper position and it should be properly placed. That's why you can see the spikes over there, which shows you the maximum value 22, but on most of the time it is around 19.6 or 19.13 and all. So mostly the temperature is around 19 degrees in this room temperature from that we got from your temperature sensor. So let us continue the design part and the development, and let us see how the data readings are being shown on that particular GUI. So the one which we already designed, yeah. So we have stopped at adding the serial port built-in function. So you have the particular part of the code which you have just copied. So this is one. It shows that the name serial port does not exist in the current context. So obviously the functionality of the serial port is not included. So we like to include that particular function. So you can go to, if you want to include any functionalities which are already built in and so on and so forth, you can use it by writing using system dot IO. You have the IO here. So using system dot IO followed by semicolon. Then another fun functionality for the ports. IO dot ports. So by you can get it a help. Yes, once you added those things, now you can see there is no red color underline under the serial port, because the corresponding built-in function has been added to your functionalities. So how do you know that? Obviously when you look for when there is an error, you can Google it and look for what are the appropriate files that are to be added into your function. So only just two files, that is system.io and system.io.ports, because the IO ports we are using in our application, you need to include those corresponding files here. Now the other red color marks, the red color marks is on the combo port, CBO port. Why? Because there is no object by the name CBO port. So in order to go for that, please go back to your designing window and go to that particular object combo port. You try to give the name for that. By default the name is combo box 1. I can see what is the name by default it is given. It gives the combo box 1, combo box 2, combo box 3 and so on and so forth. If either you can give the same name in your program, or if you want to give some other name, you can give that some other name to this and write the corresponding name in your program. So right now I am trying to give this combo box 1 because that is the name I have to use it in my program. So go back to that particular statement. combo box 1. So once you added combo box 1, obviously the red color marks has been wiped off. Similarly, the other two statements also. Yes. So once the red color marks have been wiped off, now there are no errors in my program. Now let me just explain to you quickly what is this particular set of lines belongs to. See, the combo box 1 dot, it contains some items, and those items has got some sentence also. You can see the sentence like select USB serial port. This is a sentence which you see it on the combo box when you run the application. So that particular sentence is added from the programmer point of view to make sure that the GUI shows you that particular statement, appropriate statement. That's why this particular sentence select USB serial port was added into your list of items for that particular corresponding combo box. And now here what you had, the next statement, combo box 1 got the items which are nothing but these are the list t list. T list contains, it is just an array of the set of get port names. What are the port names that are there in my computer system that are been stored in an array called array here T list. The T list contains all those particular set of port names, and the T list is been added to your combo box list of items. That is the meaning of this particular statement. So here initially, and the next statement is select index is equal to 0. So whatever the first value is there, that is index value 0, that particular item will be selected and that particular item will be shown to the user here. So once you run this particular program, after making that corrections on the error statements, we run the program. Now you see here I get the select USB serial port, that is sentence which has been added to the combo box list, and when I click it, drag down, it also shows me the COM ports that are available on my computer system. So now yes, you are selecting the COM 8, which is by default the coordinator which is connected to my system. Now select the number of data rate as well as the number of data bits. Then you need to look for opening the port. It means once you click the open port, some code has to be run at the background. What is that particular code which is going to be run in the background when you click the open port with the specified settings of your serial port? So that particular code is the most important thing. Logically, that code contains nothing but sensor data reception as well as storing the data, and the storing of the data for the appropriate data analysis. So the three things are there: collection of data, storing of data, and after the storing of data you need to look for analytics of that particular data. So how to collect the data is the most important thing. So just quickly I will go through step by step, and those step by steps configuration of ZigBees is already given to you in the form of notes. So you may try to look for those steps, so that those steps I will be doing it on the screen now, which will be useful for you to just to understand how those things are going on. Now the first step is right. Now the preparation of the coordinator. The coordinator is a ZigBee which is connected to your computer. So those coordinator needs certain parameter values such as networking, the addresses, and the sample rate. These are the three important things that we will try to give those values here. So how do you do that is, now using the XCTU is configure the coordinator with the PAN ID. So you are getting the XCTU from the dg.com support. To set up two ZigBees, one is configured as remote ZigBee used for the sensor node, and other is configured as a local XB used as a coordinator. So two XBs, one for as a coordinator which is connected to the computer, and other as a remote XB which is to be connected to the sensing nodes. The local XB is popped up into the Explorer and then plugged into the port for the corresponding configuration. So here I am just showing you the steps. Once you plugged in the coordinator, you will come back to this XCTU, go to the modem configuration tab. So here the first step is XC2 program is started and the modem configuration tab is used. That is the first step that is written here. So here XC2 is started and the modem configuration tab, this particular operation is been selected here. Then the next step is the modem type and the functional set. These two are the two important things. What modem type? The modem is used for what type? So here the modem, there are different versions are there, different softwares. So if you see here, there are different softwares, different models are available and the ZigBee. You can make use of those particular modules according to your application requirements. The one which you are now trying to set up the wireless sensor network is the mesh networking. Now depending on the topology, you need to use for different set of modules over here. Now in order to set up the mesh networking topology, you need to select the modem should be of what type and the functional set of that particular corresponding modem. There are two different values. So this is what you call it as the modem type and this is the functional set and the version. Remember, if you are connecting, your computer is connected to the internet and if you already installed XCTU, then automatically you are going to get the new versions can be downloaded. So digi.com always updates those firmwares. Basically they are called firmware. Firmware means the software for that hardware, the software for this corresponding XB. So those firmwares are getting always updated. If you want to get a latest version, obviously you can just click this button, download new versions and update your firmwares accordingly. So as of now, for our understanding purpose, I am not going to download any new versions. Already it has been updated. This software itself is the old one, but it's still the stable version of that XCTU software. That is a stable version. The latest softwares you will be getting from the digi.com. Now here, what modem type and what functional set you need to look for. So the modem which you are going to select is XB24B. Now how do you know that this is going to support mesh networking? If you look for the digi.com website and if you just search for mesh networking setup, then what are the functional modules that are needed for setting up that mesh networking, they are always available to you. You need not worry about just little bit of Google or little bit of searching, you need to do it on that digi.com, so that you will get what functional modem type and the functional set you need to choose for your wireless sensor network setup. So you are selecting XB24B. So the same thing I am going to do it here. XB24B. Yeah. So XB24B modem has been selected. And what is the functional set? So as I mentioned to you in the beginning that we are trying to do the API data transmission mode. API mode means we are trying to put data in a particular format. The frame structure we are going to create on our own. So that frame structure is been created means the frame structure is been formed based on the how many analog pins that we are considering in your application, how many digital pins, how many analog to digital pins, and what are the functional sets that you've been chosen for that particular modem type. So here we are selecting the API modem and you are making that particular modem as a coordinator. And ZNet 2.5. ZNet is another company actually. In fact, the ZNet company and digi.com together, they are doing some work here. So the latest version of XB, SB and ZB, they works with ZNet 2.5 configurations. ZNet is just a name of the company, ZNet, and 2.5 is the version name. ZNet 2 is earlier ZigBee communication. ZNet 2.5 is basically for mesh network setup here. So this current software ZNet is the one which is trying to provide modem softwares, that is the firmware softwares for XB, SB and ZB, the newer versions of that. You will see only ZNet versions will be available for you, but in the older versions you will not have ZNet. So now this is what the ZNet 2.5 coordinator API and the version number is 1147. These three parameters are being selected here and the corresponding parameter values of those modem type and the function set needs to be assigned here now in this particular screen. So that is what this particular step. If you look to the slides once again. So functional set is selected is ZNet 2.5 coordinator API version 1147. So the register ID, PAN ID, which is a 64-bit is set to 1234. Similarly, each network is defined with a unique PAN, that is the purpose of the PAN ID. Then you are setting the baud rate, the data rate. By default, the ZB communication takes place with 9600 bits per second. 9600 bits per second is the data rate which we used for our communication purpose. But later some hardware devices will be there, 1152000 baud rate can also be ascertained, depends on the application with which you designed your hardware to communicate with. So this must be synchronous. One more thing, the radio communication module and the hardware which is sending the data, both must be synchronized to each other. If the radio communication module is 9600 bits per second and your hardware data rate is around 1152200, which is not compatible, which is not synchronized with each other. So the data rate of that particular hardware device and the radio communication module should also synchronize for the appropriate data transmission to the other side of the data receivement. So these steps, make a note of this one. By default, the 9600 bits per second can be used here. So here you can select any of those values, and where are those values, data rate can be set. If you look to the modem configuration tab, you can set the PAN ID. The PAN ID is 1234. You can set the values like this. Scan channels, you have to make sure one among the 16 channels of 2.4 gigahertz frequency should be selected as one of the channels to be used for our communication purpose. Then the data rate is, if you just scroll down, you will get the baud rate here, the serial interfacing. So there are different options available: 2400, 4800, 9600, 19200. So by default 9600, you are going to select those data rates. And one more important thing, information that is to be selected is so the register IR is meant for your IO sampling rate. The IO sampling rate, the purpose of sampling rate is to make sure that the frames are sent as per the value that you are being setting here. So IO sampling is the register that is available here. You can set this IO sampling rate as 14. 14 is an hexadecimal value. Remember, whatever the values that we are sending, or we are making sure that they have been given to these register parameters, they are basically hexadecimal values. 14, which is equivalent to 20 milliseconds. 20 milliseconds is again equivalent to, what will be the hertz value, please? 50 hertz value. So 50 hertz value you are going to be equivalent for the sampling rate at which you are trying to transfer the data here. So you are just putting the 14 value here. So like this, you are just putting it the values and clicking what? Clicking the write button here. So there is a read button which is reading the modem values currently existing in the modem radio communication module. A write button is available if you are going to give new set of update the register values or giving a new values to those corresponding registers. You can click the write button. Once you give the values here and you click the write button, those values are getting updated here. Now if you see, once again, once I click the read button, the read button shows me what are all the values which are been existing over here. So the PAN ID has been set to 1234, the scan channels has been set to 12, the destination address high and the destination address low of this particular radio communication module, the serial address of high and serial address low of this becomes the destination address high and destination address low of that particular receiving coordinator. So those values have been set here. These are the minimum values. I am not showing you all the parameters. If you are doing some experimentations, then you can look for different set of values here. So as of now, I am just giving you the minimum values: the PAN ID, the scan channel, the data rate and the sampling rate. And if you are using the sleep mode, you can use the sleep mode also, but right now I am not using any sleep mode. So those are the basic set of parameter values that you need to give here. Yes. So that is the code. When you click the open port button 1 click, what is that it has been done here? Please look to the statements that are been already given as a notes for you, then you can look it on that one. So combo port text, whatever the text that has been selected on the combo port, that what you are selecting is a COM8. That particular value is been given to our serial port name. So the serial port which you are considering is the combo port which has been selected from our list of values. Then that particular serial port has been opened. This is a reserved word open function. Open method is a reserved one. You need to open that serial port. After selecting the COM port, you need to open it and set that opened serial port to 9600 bits per second. And what needs to be done is, I am calling one function called serial data received event handler. This is a built-in function for calling the function called ABC. What is this serial data received event handler? It means the serial data that has been received here, what are the things that are to be done for the received serial data. That functionality you are going to write it in the serial data received handler function, and that functionality has been written in the function called ABC. So that ABC, where is the ABC function? The ABC function is here. The ABC function is here. The ABC function, what is trying to do is going to invoke another function called do update. Now the serial handler ABC function is meant for collecting the data, and do update function is meant for collecting the data and storing the data in a separate location. So these two handlers, event handlers, collecting it and storing it in a different location, both those functions are to be written simultaneously. Both the functions has to be done. So a multi-threaded concept is been implemented here. So in order to open that multi-threaded concept, that's what you are writing two functions called this dot invoke. Invoke a function called event handler for the function do update. Do update is one function, another function is called ABC. ABC is indirectly invoking the function called do update. These two functions, ABC is meant for getting the port ready, opening the port, getting the port ready and collecting the data, and do update function is meant for collecting the latest data from that particular serial port. These two functions has to be done in parallel, in simultaneous. That's in simultaneous is done through your multi-threading here. Now look for this particular set of statements. So there is a temporary variable called RC buffer, which is an array of buffers, array of values to be taken here. So that values have been collected from the serial port read. So the read function is there, which is meant for reading the data that is from your serial port. So what ultimately we are doing is you are collecting the data from the serial port. So that serial port function, to read the values from the serial port, you need to use one function called read. That is the read function. So two important things: serial port should be opened, opened serial port should read the corresponding values, and after you read the values, that read values are to be stored in a temporary variable or a temporary array variable, rather temporary array in simple terms, called as received buffer, RC buff. I have given a name called as RC buff, which is equivalent to receiving the buffer, storing the values and putting it in an array. Array is now made as a buffer to store the serial port values to be read. And the syntax for this is how many bytes to be read here. How many bytes should be read here. So you have the number of bytes of the frame here. So if you are having a 52 bytes of storage starting from 7E to another up to the checksum, totally the number of bytes depends on the number of channels that you configure it. That means number of arrays should be held here to temporarily store that particular serial port values. Those values are to be stored here. Then the next statement is if that X value, whatever you are receiving in terms of hexadecimal values, that serial port values are received in terms of hexadecimal. So what you write is if X dot starts with 7E, clearly it states that if the frame starts with 7E. Now this is one logic I am just showing you which can be executed and which can show you the values over here. So what is that? The condition I am writing in the program is the received hexadecimal value is a 7E. Then what must be done? That is the first condition I am keeping in my program here. The received value is a 7E. Obviously you know that the starting delimiter of my frame is 7E. From 7E, what is the byte at which the channel 20th pin gives me? What is the byte at which the channel 19th pin gives me? What is the value for the channel 18th pin gives me? Channel means, what I mean to say is the pin number 20 gives me at what byte, pin number 19 gives me at what byte, and pin number 18 gives me at what byte. If you can try to extract those bytes of that particular corresponding pins, then I can store it in my temporary variables, and those values can be stored in my file. That is what the ultimate logic over here is. Very trivial logic, very simple, not one of the optimized logic here, because I will not say optimized logic. Why? Because I have just taken the condition of 7E, but as I mentioned earlier, the 7E data item can be also be seen as a 7E. One of the frames, means the frame byte value can also contain the 7E, which must be ignored as an escape sequence. That logic I have not implemented in this particular simple program, but as a programmer, if you can implement it, that's well and good. I will show you how that logic is going to be also looks like later. There is another program which can show you the escape sequence is also been taken care of, but this program will let you understand about how to extract the bytes from that particular frame. So here the starting byte is nothing but 7e. If the starting byte is 7e, obviously it indicates that it means it is basically a frame starter for me. So yes, the condition is if x starts with 7e, then what you need to do here. So what I am done here is, these are the some of the statements. Some of the statements you need to take care of. Those, the bytes values are hexadecimal values, and those hexadecimal values are converted into the corresponding byte values. And that byte values, I have given you the function called x2 byte. There is an x2 byte built-in function which you can Google it, and you can get that same function and put it in this particular piece of code. So here I have written parse of x of 42, x of 43, x of 44 and x of 45. Can you look for this particular hexadecimal values of this 42, 43, 44, 45? It corresponds to channel pin number 20. Similarly 46, 47, 48, 49, it corresponds to pin number 19. So those pin number 20 values and pin number 19 values, I have stored it in my temporary variables called ADC02 and ADC12. These are the temporary variables, and these particular values are x42, 43, 44, 45. You look to those particular bytes of 42, 43, 44, 45, they corresponds to pin number 20 only. That is equivalent to the temperature sensor value, the temperature sensor readings that you are getting here. Now the data types, what you need to give, because this is a variable, you are just collecting those hexadecimal values and they are being stored in the temporary variable called ADC02 or ADC analog to digitally converted value. ADC02, I have given a name, temporary name, that's all. You know the purpose of a variable. A variable is to hold the value temporarily in your program. So I am just collecting those bytes and putting it in the temporary variables. You need to give appropriate data types to these variables that you are using in your program. So the appropriate data types for ADC02, ADC12 are already you are given. There should be long data types. You know the purpose of long. In C programming you might have studied integer, character, as well as float, double. Similarly, there is a long data type. Long data type, obviously, you are, because these are hexadecimal values, they are going to occupy more space of if your buffer storage. So you are using a long data type. That data types declarations you can do it at the beginning of your program. That's what here. Long double type is for some other temporary variables. So ADC02 is long type, ADC12 is long type, ADC22 I have given another variable here. They are all long type basically. Long data type values are there. Similarly, there are other temporary variables called S1, S2, S3, S11, S12, S13. I will be using in my programs. They are declared under different data types. So you will be using different variables for storing different types of values. You need to give assign the separate data types for that. So for that you need to have a little bit of idea about what data type you need to be used here. So integer takes 32 bits like this. An integer, depending on the processor which you are running, the computer which you are running, a 64-bit computer takes 64 bits of data transfer. You need to give appropriate data types here. So once you take that particular hexadecimal values of appropriate positions for pin number 20, pin number 19, pin number 18, pin number 19, so on and so forth. Now ADC02 contains what? ADC02 contains the values of byte number 42, 43, 44 and 45. Those ADC values are being converted and they are being stored in the ADC02 value. Now that ADC02 value is again multiplied by 3.3 and divided by 1023. Can anyone have an idea why I have done this one? This is getting the temperature values in appropriate readings. So here the appropriate values, the conversion formula you will get it from the data sheets of that particular temperature sensor. Because I am using the TEM31 or TEM32 is the temperature sensor you are using, you will get the data sheet values will be there. What is the corresponding temperature degree values? You want to show the temperature in degree values, degree Celsius values. So you need to convert that ADC02 value converted into degree Celsius values. Those corresponding formula is nothing but 3.3 is the reference voltage which you are giving here divided by 1023. And minus multiplied by 1000 minus 500, you get the appropriate temperature degree Celsius values. So that is stored in which particular variable? That is now stored in the variable called S1. So I am storing the temperature sensor values in the temporary variable called S1 here. I repeat once again, I got the corresponding pin number 20 values like 42 byte, 43 byte, 44 byte, 45 byte into a temporary variable called ADC02. The ADC values which has been got is been converted to corresponding degree Celsius, and that degree Celsius value is going to be displayed on your text box. The text box which you are going to see it now, I will show you here. And just look here, one more condition I kept it here. If S1 is greater than 22, what does S1 is equal to? S1 is equal to 22. Any idea please why I have made the limitation here? Yes, they fix the upper value. When there are spikes here, it should not exceed. So that value you can see it on my running of the screen. So after getting the values of S1, so S1 values contains the temperature values. Similarly, ADC22 contains the pin number 19. Pin number 19 that contains again conversion is 3.3 into ADC22 values, that is been stored in your another temporary variable S3 and the corresponding S2 values. So now the condition comes here. If the combo box dot selected item is equal to station 1, it means the station 1, when I am running the execution of my user interface, I will be selecting from which particular sensing station I am collecting the data. So if the selected station is station 1, what does it mean? You whatever the values you are going to collect it here, put it in the text box 1.text is equal to the converted value. Similarly, text box 2 value is going to be connected to the corresponding analog to digitally converted values. So here S1 values, S1 is formatted to put up to 2 decimals or 1 decimal according to your application. If you want to display the degree Celsius value into appropriate decimal values, this is the conversion formula, up to 2 decimals here. S1 value is converted to 2 decimal values, and that S1 value is stored in SS1. SS1 is displayed in the text box 1 text. Similarly, the text box 2 value is going to be displayed. Now coming to these remaining lines, stream writer, file stream, I will come back to that later. How to store the values in a file, that is file handling steps are there here. But as of now we have completed on displaying the data onto the text boxes. So this is text box 1.text, this is text box 2.text. These two text boxes, text box 1.text and text box 2.text, contains the sensor temperature and as well as the potentiometer values. So those two values, if you run and see now here carefully, before that I would like to show you here, go to the design point. So this is equivalent to nothing but basically this object is a text box. This is text box, you can see the name here, text box 1, text box 1. And what is this particular box? This particular box is also a text box object which is meant for showing the potentiometer value, and that name of the text box is text box 2. So the naming I have given here, this is one text box and this is another text box which are meant for showing the temperature sensors and the analog to digital converted potentiometer values. So when you run this particular program, so once how do you run it? Once again I am just showing you to look for the values here. Select the serial COM port COM8, select the data rate, select the data bits, select the station. Now I click the open port. Yeah, now you start receiving the values over there. Sensor temperature 1, yes, sometimes it's showing 17, 18, 22. 22 is the upper limit that you have fixed in the program, so that if any value exceeds, I know that the more than temperature on this room cannot exceed 22. Of course, this is not just falsifying that particular system over there. We are trying to make sure that how we can also ascertain that the limits can be put on that particular values. That's what I would like to have shown you, that particular values. And the text box 2 contains the corresponding potentiometer values, which is already fixed at a particular point, that is 3.3 volts. And the below box shows me the hexadecimal values, which you can also monitor what is the hexadecimal value, 3.3 volts below the potentiometer values. So we are trying to receive the data from this sensing device up to that particular coordinator through wireless. That is what the data is that has been received from this particular sensing station. Similarly, if you put one more sensing station over there, then you need to select the station 2 for the corresponding thing. Then station 2 corresponds to that particular corresponding address of that particular respective temperature sensor values. Now that's what you are receiving the values over here. But I did not show you how to store the values here. Now they are storing the values is the most important thing for data analytics. Now here storing the values can be done according to your application requirements. I will like to share with you two different types of storing the values. One is directly you can store the values in a file. From that file you can take it to any analytical processor or any other analysis software which you want to do it analysis. You can do it as an offline, but the offline analysis is not that much appreciable because of the today's real time situations of Internet of Things is concerned. So, Internet of Things is concerned, obviously you need to do it in a real time. So, there are two things here. One thing is storing the data in a simple file and take that file for analysis later, or storing the data in a database in a proper way and doing the analysis. Excuse me. Yeah, storing the data in a database server and trying to do some analysis on the database server properly. So, how do you store the database means, I hope you may have heard about the word Vamp Server, Windows, Apache, MySQL and PHP. Those are computer science savvy people, they will be able to understand Vamp Server or LAMP server on a Unix platform or on a Linux platform. It means there is in that LAMP server or Unix platform, you have the opportunity to use the MySQL server, which are open source. Now, whatever the softwares I am telling you is basically the open source, and these are basically the evaluation versions. So, you can do practice on, you need not buy those softwares, you need not evaluate. So, using a Vamp server, you try to install it at a database server and you can connect from the C# program to the Vamp server. So, from the Vamp server, once you collect the data onto a database server, then you can directly pop the data onto the website. That is one thing. Or you can, if you have your Vamp server, you can configure today's technology, your cloud computing. I hope you are aware about Azure cloud computing, as well as the Microsoft's other cloud computing service providers are there, wherein you can configure your Vamp server to directly send it to the cloud also. So, MySQL server can be directly connected to the cloud. So, if you are able to store the data directly onto the MySQL server, then the MySQL server is configured to the cloud. Obviously, you are sending the data, whatever the data that is collected on this wireless sensor network, you can directly pop it up to the cloud as well. That is also, we have done the practice on that one. We are able to generate and we are able to store the files there also. Now, I will show you how to store the data on a single file. So, storing the data on a single file is like this. Just continuation of the steps here, we are able to get those ADC values converted to the corresponding temperature values, and now you need to write, if you want to store it in a particular file. Suppose I have given one file called file101.txt file, this ordinary notepad editor file, text editor file, where you can store it on a file itself there. So, but there is some syntaxes. If you Google it, how to write that files, how to handle the files, you will be able to get the solution easily. But let me just show you some of the steps here. There is one stream writer called as functionality is there, stream writer. Using that stream writer, you use one object called writer or file stream, and that file stream is connected to a particular file of your computer. That is what the connection string is. That was the connection statement, which you can look for syntax. There is no need to worry, you can Google it, you will get the correct syntax for how to connect your file stream writer to your corresponding file. Then file stream dot write date time dot now, it means what is the current time, current date and time. There is a function, there is a built-in function date time dot now. Similarly, file stream dot write, after date time write I am adding one comma there. Then file stream dot write text box 1 dot text, whatever the text box 1 is showing me the value, that particular box value has been written to that particular file. That file, I will show you the file which we are going to write it there. Now, the another one is similarly file stream dot write comma, after writing the text box 1 value, put a comma there. Then file stream dot write line text box 2 dot text, text box 2 contains the potentiometer values, that analog to digitally converted potentiometer value. So, what I am storing, the current date and time, the temperature sensor value and the potentiometer values. Those three values I am just storing it in a file called file101.txt file. Where this file 0101.txt, it is present in a folder called ABC in a drive called C here. Let us see that particular writing of that particular files. Before we start writing it, so on the C drive, on the folder ABC, there is a file called file 101. You need not worry, even if the file does not exist, it will create that is the syntax of that particular file for you if you are writing the file handling. If you open that file, now these are all the values which have been stored at different points of time. You don't worry about all this one, there are some values which are there here. Okay, if you look to the current time, that's what the 9:59 p.m. according to this laptop time, you will get the date, time, the temperature sensor values and the potentiometer values which are separated by commas. That's what you are trying to store that particular values onto this particular system. So let us see whether this file gets updated data or not. Yeah, some values which you have just collected 18.48 and 3.3, some values which I have now received here.
Sir, what is the role of potentiometer in this case?
Now this in this setup, this is just a setup. Now what is the role means, basically we want to make sure that even if you change this potentiometer, the changed values can be seen on this particular screen of the potentiometer. That's to see that the real time changes of that particular sensing device, because you may not, I mean sometimes people may not appreciate the temperature sensor, because temperature sensor readings does not change quickly. So in this,
Resistive sensor.
sorry sir,
It is just a resistive sensor.
most likely that is the same thing only sir.
Resistive sensor.
Just to change, because temperature does not change immediately. People will not understand whether they are really getting the data or not. Just to in case manually need to change it, obviously just little bit of tilt it to a particular degree, automatically you will see the change in that particular value. That is the purpose only. Yeah. So these are the updated values that we have just received here now. At 10, just now we received, is almost 10:01 now, 10:01 p.m. New Zealand timings these are, the laptop is configured for that. Anyway, that is the time, 10 at 10 we just received those all values. Before that one 10, so these are the samples actually. In fact, each sample is one. So almost in 1 second you should be able to receive 50 samples. So obviously 50 into 60 samples should be received in 1 minute. But how many samples that we are received, you can see, just you can count, it will be less than 50 only. Then why you are unable to receive that many number of samples? That is the question mark here. It is not a research question, rather just this is only a programmatic question. Can anybody just try to highlight on this one? Because as basically we configured for 50 Hz, 50 samples in 1 second, but in 1 second we are able to receive only around 20 or 30, on an average 25, 26 samples only. The purpose here is, yes please, the program, no, we did not keep any delay here. The problem is on the program, on the software. The software, if you look back to the program what I have written there, the logic, yes, the logic is not optimal. That is not the logic of optimal logic, means the program is not correct. In fact, the program is just a simple program to show you that yes, the program can be written like this at a starting point of the program. The starting, what is the idea of that program? Let us look for the 7E. Sometimes you will not get exactly at 7E to 7E. You will not get every frame to 7E to 7E. The data rate at which that samples are being sent and the program at which my program is receiving it, some samples are been already lost. Some samples are lost in just looking for the condition of if the hex dot starts with 7E, that is statement I have shown you already. That is one condition. And the condition number 2 is another I have written that if the combo station is station 1, by that also that condition, by that time the some samples have come and some samples have lost in the process of storing the data. So ultimately out of 50 samples in 1 second I was able to store only 30 samples. That is the program strength, that is the performance of the particular program. So obviously the most important thing here comes in the picture of writing a program in a proper way so that you will not miss those samples. At least out of 50 samples you will be able to receive 45 or 46 for appropriate analysis. If you want to do proper analysis, obviously you have to receive actually all the number of samples correctly. The ideally 50 samples should be there, but the way you write it in a real time, then it comes the conditions like how do you write that particular program so that you will not lose that particular samples. It is not because of delay, but the conditions that you kept it in the program, that conditions are eating away the samples which are arriving to the serial port.
Can we use big data streams for this type of thing?
Big data, yes, of course, yes.
Real-time data collection?
Yes, exactly. We, in fact, even I am personally doing some work related to the big data analysis only. So here the same conceptually the principle remains the same. You build up the wireless sensor network here. Now with this principle I would like to share some ideas. I hope professor might have given you some ideas, means what exactly we have published some papers and what prototypes we have developed. Some prototypes we have developed, some electrical sensing units. Have you seen the pictures and all? And those they are connected to the Internet of Things theme, and we are able to measure the throughput, we are able to measure the latency, we are able to measure, means with the number of available sensing units. How many sensing units are there? We have around 8 electrical sensing units were there. I hope you know the scenarios and all. No, if not, at least just I would like to just take 2 to 3 minutes here, because that sensing units is very important. Once you understood what exactly you have done, with the same principle, with the same ideas of writing the programs, we are able to develop some prototypes, and those prototypes are tested in the real situations, in the real smart home, means the old home only we made it as a smart home, so that those appliances can be used there, as well as we can control those appliances too. Controlling of appliances through remotely is the logic of nothing but making this LED on and off. That is the logic which we have made for that particular system to work. So here, and other sensors like pressure sensor, the force sensor which is put beneath the bed for the chair to monitor whether the person is sitting on it, and the other objects here on the home. This is for the door open and close, refrigerator door open and close, for the drawer of the table whether it is open and close, and this is another one, environmental parameters like temperature, humidity and light intensity measurements. All those systems which are being placed at different parts of the home, they are located in the different parts of the home, and those data are being collected by one coordinator, like the same setup what you are using now here. Each electronic devices are being fabricated, the conditioning circuit is made, and those electronic appliance is being monitored when it is on and when it was off, and that data was collected there, and that data was analyzed for determining how well that particular person is able to do his regular activities of your daily living. That was the data analysis part there. Now this is one paper which you can see here, the analysis part. Of course this is done in an offline one, but later on the beta 1, beta 2, this can be also pictorially represented how those devices at different dates, those devices are being used by those particular person. This is one paper which was published in 2012, and I am very much thankful to professor. I just tried to take this opportunity, and last week only I have seen the number of citations of that paper is almost 100 plus, 120, and that particular paper which was published in 2012, that is my first sensor journal paper, with the help of professor I have done it. Till today also people are still downloading that papers after 4 years, means almost 5th year this is, and that work which was carried out, we are very much thankful to sir. Still that particular people are able to still refer to that particular work, and still they have been still citing those. So far 120 citations were there. Of course there are some of our paper only, but apart from that, at least I can tell guarantee around 70 to 80 citations of some other people. At least they are referring to that particular one particular single paper. Not only that, there is another paper on Internet of Things, Smart Sensing Scheme for Human Emotion Recognition System. where just let us see something here. Now you can see, you can try to categorize the human emotions. How did we integrate that human emotion recognition system with home monitoring system? Because we are able to integrate both the systems together. Both the systems have different set of platforms, but we are able to integrate. How it was done means, because that is the advantage of having your own system rather than going for some other systems here. So here there is one skin temperature as well as the other parameters of the body can be monitored here, and this is the device. This is the device. When a person puts his hand on that particular device, it will recognize the skin temperature, the body temperature, and so on, and like this. And remember, this is also integrated with XB. If you see here, there is an XB over here. This XB is transmitting the analog as well as analog values of this particular body temperature, the skin temperature, and other parameters. From this you are getting the XB. The XB is integrated here. Similarly, these are the emotions carried upon. Simultaneously, you can build up the system with the home monitoring system, because the home monitoring system also works with XB. Human emotion recognition system also works with XB. Both of them are working with the same XB principles. You try to collect the same analog values and integrate the human emotions as well as the home monitoring purpose. That is the advantage of having the same platform which is depending on the same communication medium. Same wireless communication system, the XB communication system itself is used in having those two functions of that particular modules to be integrated. Similarly, like this, we have different set of papers are there, which you can browse it with Professor Subhash's name. You will see different papers there. All those papers, I can frankly say that all those papers which consist of electronic appliances works with the same principle, this small principle itself. If you are able to design a system like this, write a software program in which I was trying to show you that how to write, what are the things that are needed there. I am not showing you the complete program because of the time constraint, just I have briefed you about those things, and those program is already available to you. And the steps involved in for step 1, step 2, step 3 and all, sir has made a given as a book chapter. The book chapter.
If you need any more, just let me know. We can provide some way.
Yeah, the soft copies are available with sir. You can collect it, or you can as well request me to email. Then I can send it from my bank. I have the other hard disk is there with me, so I can send it through your email. So this is the things I would like to share you here. One thing, the last one is on the LED on and off, so that we can send a signal from that to this one. That completes that particular sensing data parts and the data reception and the other parts of this. The address, which because I will be sending the address from the coordinator, so that already we have made this particular LED to off. Already previously when we are configuring the XZigBee, I have shown you, you have given the value of 4, it becomes an off here. Now we will send a signal from our program, develop program, so that we will see how this can be made on, and what is the corresponding source code. How do you write that digital signal on and off? That logic, what I have written there, I will try to show you that one. So let us first see whether this is working fine or not. The orange color light is not glowing here, red and green are just glowing here. So I have started receiving the data. Obviously the data is getting received here. Now at this point I will give you the address here. It is 40 9B 7E C7. So still I am continuously receiving the data here. Now I am selecting it as on and off. So once it is already off, I am making it as on here, the orange color light. Yeah. If anybody can hold it, then you can come to know here. Orange color light, maybe some reflections of red color lights there. This is the orange color light which is now on. Now we will make it off here. So how to make that on and off? That is the programming part which you need to look for. If you look to the source code, so here in the coordinator, if you see carefully, the RSSI, receive signal strength indicator, it is always glowing here, and there is also a green color blink is coming here, which is showing that the data is getting received here. So without seeing there also, you can try to assume that in the real situations this is the most important. When you are doing some practice or exercises or trying to do some kind of practicals initially, you will not know whether your program is wrong or whether your data transmission is having a fault. At least by looking to these signals, I can immediately know that there is a communication is happening. That will give me a clear indication that communication is there, but my software part is not correct. There that comes in the picture of how do you try to at least troubleshoot your things, whether the communication problem or software problem, how the things goes on. So at least by looking to these signals is very, very important that communication has been done or the software part is wrong. So in the program, if you go to the program, so remember what is this particular objects are. So this is which particular object? This is combo box 1. The name of that particular object which we designed is combo box 1. Now that combo box 1 is made as on and off. When it is on, what parameters or what values did you send? When it is off, what values did you send? That is a point of logic here. So if you look at the particular program, here comes the logic of if combo box text is equal to on, the combo box text value is equal to on. What did you do is we have made that what is present in text box 3, what is present in text box 4, what is present in text box 5, text box 6. Those text box 3, 4, 5, 6, they are nothing but basically the addresses, the serial low addresses of the remote sensing unit, the serial low addresses of your remote sensing unit. Those corresponding values are being set with an on option. It means what is meant by on option? On option is another function which you have written now here. That is a function which I have written on option. What is that on option function is doing? So this is the on option function. Look here, what is that on option function is trying to do here is, this is the on option function. The on option function, the value is on, then get that corresponding text box values into temporary variables 1, 2, 3, 4, and those temporary variables 1, 2, 3, 4 are set with the values, and this is the frame. What is the frame I have written here? The frame which I created here is first value is 7e, the second value is 0, 0, the third value is 1, 0, the fourth value is 1, 7, then the fifth value is 0, 5, and the sixth value is 0, 0, 13, A2, 0, 0, it follows on. So can you tell me what is this particular set of values are? In the beginning of the program execution, sir has asked me about one frame to be sent to make the remote ZigBee on and off. The command, that frame command consists of this particular value only. 7e is the starting delimiter, 0010 is the length of the bytes of this particular frame, 17 indicates making digitally on, that is a command that is followed there. So this through program you are creating a frame, nothing but ultimately you are creating a frame, and that frame is being written to where? It is to be written to the serial port. It means you need to write that frame values to the serial port so that the coordinator sends that values to the corresponding remote ZigBee. That's what the logic of this particular program here. So get those values. This is the complete frame here. 7e 0010 0013 A200 is the higher order address bits, followed by 0013 A2 00 then FF followed by 02, 44, 32, and finally you are making that value as 5. 5 means making the value as on. So that values you have ascertained into these particular variables of A1, A2, A3, A4, A5, A6, A7, A8, A9, and those values are being written into serial port 1 dot write all those the hexadecimal values mx1. The mx1 consists of n1, n2, n3, n4, n5, all those byte values are there. Those byte values are being written back to the serial port 1. It means that frame is being written ultimately, so that you are making it as on. Similar logic is applies for off option. What is that off option is to be done? Instead of making it as on, you are making that particular off option as select the frame, means create the frame 7E00 10 17 05 00 13 A2 00 followed by, at the end if you want to make it as off, the value should be set as 04. 04 makes you, this is the 04, the last value you are making it as 04. 0 makes you data output low, 05 makes you data output high. So when you select an off option, you are setting that particular value as 04. It means it should be off value, and that particular values, the variables, the variables values are being set to the again serial port write. So you are just writing that particular values to the COM port write and read. Serial port read reads the values from the serial port write writes the values to the serial port. So the new values are been written here, new values are written to make on and off, whereas read option meant for only collecting the values and storing the values in the variables and storing those values of the variables in the corresponding files. And if you want to store it in a web server or a database server, there is a software here that we call it as, this is the one which you are using here, called as Vamp Server. Windows, Apache, MySQL and PHP. Vamp is an acronym for Windows, Apache, MySQL and PHP. What is Vamp? It works on Windows platform. This is a Windows operating system. Apache is basically a web server. Apache is basically a web server. WAM. M stands for MySQL and P stands for PHP parser. If you are writing web scripts, means web pages you are writing, you can use those parser to generate the web scripts. It means you can use this particular Vamp server. That's what you can see it here. You are on it, the Vamp server is on. You can make use of this Vamp server to store your data. Your data from this coordinator, can be stored on the database server. And you can create your web pages, and from that web pages you can show your sensor data values on your web pages. So again, that is another issue. From there also you can send the data to your cloud and do your corresponding analysis there. So once you store the data onto a database server like MySQL, no need to go for Oracle, no need to go for MySQL SQL server. MySQL is the most preferable one. We are able to run continuously, we are able to store the values on this MySQL for almost more than 1 month continuously without stopping your program, without stopping our sensor data collection. We are able to collect the data here. Once you are able to collect the data onto the database server, the remaining parts comes your analysis. You can use RStudio. I am telling you RStudio or R programming language, which is also an open source, basically a statistical processing software. Yes, the statistical processing software, the statistical analysis can be done. You can directly connect your MySQL server to your R to analyze your data. The most important crucial part is only data collection. Analysis parts is not that much very concerned for us. Just the only integration of those corresponding softwares from MySQL server to your RStudio. As well as you can connect as well as to your MATLAB also. You can connect as well as this MySQL server can be connected to your MATLAB. Those who are familiar with MATLAB, you can directly analyze the data onto using your MATLAB too. That is the two other options for you. If you really want to show the data onto the cloud or onto the websites, this is the most appropriate one. We were able to show this on and off continuous monitoring on the web pages. Continuously the system was able to run. Only the issues will be pertaining to those softwares here. The first and the foremost thing is your sensor data collection or sensor data acquisition software program should be very much robust enough and should be able to run continuously for days together, so that you can get ample amount of data for your analysis. That is the thing. Usually what happens is, the more robustness program you write it, obviously the program will run for a longer period of time. It should be a continuous one, 24 hours, 7 days a week. Your program is not just only for testing for 1 hour or half an hour or just like 2 minutes or 1 minute like this. No, the program should, yes, the program should be the same logics, the same principles, the same design, we followed it, we are made that systems run for days together. That much assurance I can give you. Sir.
I think you can just add few things about that uploading that to the internet and privacy and security.
Yeah, right. Sorry, yeah, sir. Regarding the uploading data to the internet, the securities and privacy issues. Let me just brief you about here the security issues of this data transmission. Now, for the wireless sensor networks, there is no problem in the security, in the sense that these DG people, they taken care of sending the data securely. Usually the data has been transmitted using direct sequence spread spectrum. That is what I was telling in the beginning. Frequency hop spread spectrum, these are the different technologies. Frequency hop spread spectrum, direct sequence spread spectrum is the different technologies that we use it on our wireless transmissions, where the data is encoded in that particular formats. So, the ones which you are receiving here, the 7 is followed by the corresponding data, that is a secure data, there is already encoded data, it cannot be decoded as far as the wireless sensor network is concerned. But once you receive the data and store it in your computer, like once I have shown you there comes the security aspects, and from there when you push it onto the cloud, again the security aspects comes here. Much of the work can be done as of now, that is basically studied under the IoT security or cloud computing security. Under these two headings, people are doing a lot of researches on the security and the privacy issues of cloud computing security and IoT security and privacy issues. Because once you send the data onto the cloud, obviously that cloud server is maintaining the data at different locations. Third party service providers are there, their issues comes of cloud computing. People are incorporating several security ideas, security technologies they are trying to incorporate. For the last 2-3 years onwards, much of the security works have been done related to cloud management, the cloud computing as well as the IoT. This IoT and cloud computing are interrelated to each other. More or less they are overlapped to each other. Both the ideas of IoT and cloud computing comes together only nowadays. So, both are been having the same issues of the security issues. People are doing like how to secure the data on the IoT and cloud computing with the same principles, like how do you secure the data on the wide networks, what you do it over here. Only thing is the applicability, that what the people are looking for, still a research topic. I am also very novice in that particular area about what exactly the security. You need to again explore the ideas what people are doing, still doing only. There is no optimal way of securing that. You need to incorporate on your own strategies. Since the data has been stored in the form of hexadecimal values, almost the data is secured. In simple terms, I can say at this point of discussion. There is no point in intrusion is not there. Intrusion can be only done, only changing of data is happening because of interferences, and incorrectness of data is coming because of the data program that is being used that is not properly written. Other than that, there is no issues on the security of wireless sensor network is concerned. Wireless sensor network is highly secure, highly robust, and the most reliable. Throughput is more, latency is less, as the data transmission is appropriate for different set of home monitoring applications and the Internet of Things theme. The background for Internet of Things or cloud computing is ultimately on the ground is the wireless sensor network setup. If you are able to develop the system to collect the data, store it, yes, that will be the most appropriate thing that will be helpful for the Internet of Things as well as the cloud computing. Much of our works are related to this only. Please, the citations are there, many papers are there available on the Google Scholar, IEEE Explorers with surname or with my name. Papers are easily downloadable if you have IEEE Explorer digital library. You can go through those papers. If you are having any doubts, please let us know. We will try to help you as much as we can. The citations are many for the last 2 years only. In the last 2 years, my citation count has increased to 700. All credit goes to Professor Subhash, and I am very much thankful for him, because at least he has given me the opportunity to work for him, and obviously it has build up some ideas and incorporate those ideas when the infrastructure is given to me. That was very good. So, citations are there, yes, ideas are very good. Internet of Things themes are very much helpful for you. Security aspects and privacy always will be there. It is not that one particular thing is secured, no. Always explorable, must much work is needed in this particular two aspects, that you need to explore it on the sites. Only thing is, one thing I can tell, because as a reviewer I can see from MDPI sensors as well as IEEE sensors, I used to review papers on security and privacy. I could see much of the work is carried on where people, whatever they do it on the ground with the wide networks, the same security mechanisms they are trying to replicate. They are trying to same duplicate or replicate it onto the cloud itself. The same ideas they are going to exhibit over there. There are nothing new ideas as such. Only very few people are doing that much. But one thing I can tell, whatever the things like how the security of data is taken care in a wide network, same concepts, same ideas, same principles, they have been followed for the cloud management also. That much I can tell you comfortably.
Some interaction, some ideas, you can discuss with you. Yeah, and I just want to add, as Nagendra told many times, the professor opportunity. I mean, any professor will be very much proud of having a student like Nagendra.
Yeah.
And I told that our background is engineering, and before Nagendra, I used to think that computer science people, they hate electronics, hardware especially. But he actually showed that we cannot draw a line. If you think of a system, it's combination of everything. And Nagendra, because of Nagendra, our lab became a real lab of real work. So I am very much proud from that point of view. And as I said, I mean, any supervisor will be very much proud of getting a student like him. So I would like to thank him because he took all the trouble from coming from Hyderabad only for you guys. Because me and Tarikul were giving the sensor perspective, but he is telling you the IoT and other things. Because of shortage of time, still we could not, he could not tell everything. But if anybody is interested to get the program what we have developed, which is quite old, but if you think that will help, ask him, just send an email after a few days. We will be happy to give that either in the form of Dropbox or in the form of some way. So that will not be issue. Getting paper is not a problem. Papers are available in the public domain, but the program what he has developed, if you think that it will be useful to start with, don't hesitate to ask. Okay? So thank you.
So that's actually I want to give one small moment. I just request. Thank you, sir. So today we are ending our schedule. Tomorrow is the last walk. You can say the last lectures will be there before 1 o'clock, and from 2 o'clock we have a test, evaluation test. Actually, evaluation test we are making in module 1 and module 2 way. So first part of the question will be based on module 1, that is smart sensors, different parameters, and module 2, which is wireless sensor network and Internet of Things. So this is in fact the requirement of the GIAN people. We have to fulfill their requirement. So it is not just like a test, something like that, but it is a evaluation test tomorrow at 2 o'clock once we take the test. And 1:31 we are going to have analysis. And there should be one lecture also that will be delivered by Professor Subhash Chandra Mukherjee. That is for management to give some idea what are the things that you have to remember while writing research paper. So with this I will stop now. Thank you very much once again.